Hello, Pirates. So far in Unit 5, you've talked a little bit about acids and bases, and at this point you should be able to identify a substance that is an acid and a substance that is a base, and also something that is a salt. We're going to talk about a pH scale today, and you've probably heard the term pH, but you might not know really what it means. The pH scale is used to tell whether a substance is acidic or basic. So, with that said, let's take a look at the pH scale in the first diagram here. The pH scale runs from 0 all the way up to 14. So the important part is to look right in the middle here at 7. Anything that has a pH value that is less than 7 is considered an acid. On the other side, anything that has a pH value above 7 is a base. They use the term alkaline. Alkaline and base are the same thing. And another aspect I would like you to look at is the further you get away from 7 on the left side, the more acidic you become. Right? On the right side, the further you get away from 7, the more basic you become. So they have some arrows at the bottom that show you that increasing acidity and increasing alkaline. So take a look at the next diagram here. And the next diagram just gives you several household substances that you're probably familiar with. Let's zoom in a little bit there. And you see at a pH of 7, neutral. Above it, all of those substances are basic. And notice at the top there, you've got some cleaning substances, ammonia, soap, detergent. Yeah, cleaning substances are basic. And look below 7, a lot of food items there. Yes, we do eat things that are acidic. So a lot of familiar items there. All solutions will have a pH value. So what we're looking at is what's the pH value as an acid or a base? We can tell by looking at the pH scale. All right, take a look at the next information here. And it says, well, what does pH mean? Now, pH is the power of hydrogen ions. So hydrogen ions really is what makes a solution acidic. The more hydrogen ions in solution, the more acidic it is. So pH, power of hydrogen ions, it's a logarithmic scale. So what that means is every time you move one spot on the pH scale, it's a power of 10. So it's a little tricky there. So take a look at the first one. Let's put this one here. Let's highlight this guy and let's put him in red since he's an acid. If you have a pH of 1, well, the hydrogen ion concentration is 1 times 10 to the negative 1, or negative first. And if you were to convert that number into a decimal, it's 0.1. Okay, makes sense. Well, let's compare that to a substance that has a pH value of 3. If you have a pH value of 3, your hydrogen ion concentration is 1 times 10 to the negative 3, your third power. And if you convert that to a decimal form, it's 0.001. Now, I know in your quick quiz, there's some questions that say, how much more concentrated is a pH of 1 than a pH of 3? Well, let's write that up there. If you're going to go from a pH of 1 up to a pH of 3, how many times more concentrated is the pH of 1? We know it's more acidic, it's further away from 7, but how many times more concentrated? What you have to remember is the pH scale is based on the power of 10. The next thing, to go from 1 to 3, you have moved 2 places. Well, it's based on the power of 10. You move 2 places. 10 squared is 100. A pH of 1 is 100 times more concentrated than a solution that has a pH of 3. Some kids don't like that, so they say, well, just take 10 times 10. Can I do that? Of course you can. That's still 100 times more concentrated. All right? Let's erase that. We'll try one more. So let's get rid of this. And let's just pick 2 more. Let's say we've got a pH of 3. Still acidic. Oh, I used the wrong one there. Let's get rid of that. Let's go pH of 3. Let's do it with the highlighter there. pH of 3. And let's compare that to a pH of 7 since it's neutral. I'll put that in green there. All right. So we know a pH of 3 is more concentrated. It's more acidic. So if we want to see how many times more concentrated is a pH of 3 than 7, we're going to go from pH 3 over to a pH of 7. And we know the pH scale is based on a power of 10. How many places did I have to move to go from 3 to a 7? 4 places. So 10 to the 4th power is going to be 10,000. So a pH of 3 is 10,000 times more concentrated than a solution that has a pH of 7. And if you don't like doing 10 to the 4th, you can always go 10 times 10 times 10 times 10, and that's going to give you the same number, or 10,000 times more concentrated. Okay, so hopefully that helps. The pH scale is a logarithmic scale, and every time you move, it's by a factor of 10. All right, there's a couple blank spots in there. You can probably figure out what those are. We'll write them in real quick. If you have a pH of 14, well, you're 1 times 10 to the negative 14th power. And if you had to write down in decimal form, 1 times 10 to the negative 11th, wow, that's a lot of zeros, but it'd be a decimal then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you're 1. So, and I'll erase the other ones around it so we don't get confused. So there you go. If you had to fill in a chart, I don't know if we'll have to do that or not. So let me erase this, and we'll go to the next part real quick. Oh, erase it. Use the correct buttons. There we go. This next chart is pretty interesting. We know anything below 7 is acidic, and anything above 7 is basic, and that's really what this is telling us here. All right. Above 7 basic, below 7 acidic. But I want you to look at the hydrogen ion concentration, the H+. All solutions, whether you're an acid or base, they all contain hydrogen ions. Acids have a lot higher concentration of hydrogen ions than bases. And you can see that by the relative size of the H in the brackets there. There is another ion that is also found in solutions, and it's called hydroxide, or OH. And look at that, it's really the reverse. Bases have a lot of hydroxide ions. Acids have some too, but they don't have that many, or a very low concentration of hydroxide. So all solutions have hydrogen ions, they also have hydroxide ions. Here's what I find interesting about this. We know that water is neutral, right? Water has a pH of 7. Well, for water, the hydrogen ion concentration is equal to the hydroxide ion concentration. Since we're talking concentration, let's put that in brackets there. So if you increase the hydrogen ion concentration, you become acidic. If you increase the hydroxide ion concentration, you become basic. But all solutions have both. Water happens to have an equal concentration of both of those. So pretty cool chart. All right, let's move along here. Last one here. We'll do a couple sample problems, or 5 sample problems. I think this will help you out. And I think the diagram at the bottom is pretty good. So here we go. Which substance is considered to be more acidic? A substance with a pH of 5 or a pH of 3? Well, we know that they're both acids since they're both below 7, but the further you get away from 7, the more acidic you are on the left-hand side. So 3 is further away from 7 than 5 is, so let's do this. Let's circle pH of 3 would be more acidic. Go to number 2. 2 says which substance is considered to be more basic? A substance with a pH of 8 or a pH of 10? Well, they're both bases because they're above 7. Which one is further away from 7? Well, that would have to be the pH of 10. Okay. Number 3, we did a couple of these earlier, but I think we should try one more. It says, how many times more concentrated is a solution with a pH of 2 compared to a solution that has a pH of 5? Well, we know if you're going to go from a 2 to 5, you have moved 3 places. And we know that the pH scale is based on a factor of 10. We've moved 3 places. So 10, oh, that's not a very good 3. Let's write that 3 over again here. So 10 to the 3rd power is 1,000. Or you can say 10 times 10 times 10. So a pH of 2, the hydrogen ion concentration is 10,000 times more concentrated than a solution that has a pH of 5. All right, I'm going to erase that just to get it out of the way there. All right, ooh, wrong guy here. Let's get rid of that. There we go. Delete. Okay, number 4. A substance with a pH of 3 is and your choices are acid, base, or neutral. Well, the pH is below 7, so that has to be an acid. And its hydrogen ion concentration is how many times more concentrated than water? Well, if you're going to go from a pH of 3 to 7, that tells us how many places you're going to move. So 10 pH scale is based on the power of 10. We've moved 4 places, so 10 to the 4th is going to be, let's put it right up here, 10,000. And if you don't like that, you can take 10 times 10 times 10 times 10. That'll give you the same thing, 10,000. So every time you move, it is based on a factor of 10. And the last one there, I'm going to erase this just to get it out of my way. I do that every time. I got to stop that, get rid of this, delete. Okay. This one, a little bit tougher, but I think we can do it. It says a substance with a pH, it should say pH of 11, is a acid, base, or neutral. If it's above 7, it's a base. So let's write down base here. I'll put that in blue since it's a base. Above 7 is a base. And its hydroxide ion concentration is how many times more concentrated than water? So we're going to go from 7 to 11, and we know, okay, bases have a very high concentration of hydroxide, so the scale is based on a power of 10, okay, and we've moved 4 places, so 10 to the 4th again is going to give us 10,000. So we went from a pH of 7 to 11, and the bases are going to have more hydroxide than the water. How many times more concentrated? We've moved 1, 2, 3, 4 places, 10 to the 4th. It's 10,000 times more concentrated than water. So hopefully that helps you understand pH and how it relates to acids and bases. And good luck on your quick quizzes, guys. Take care.